All right, here we are at Chapter 2, Lesson 6, Estimate with Percents. This is on page 137. All right, our learning objective F is I can estimate the percent of a number. So estimating is fun because we're going to be rounding up to some numbers that are really easy to work with. And this estimating lesson is going to get our brains ready and get a sense of finding the percent of a number before our next lesson where we actually calculate the exact percent of a number. So this is just estimating in this lesson and getting an idea of what we mean by finding the percent of a number. We are going to start by looking at the real world link. Ooh, movies, fun. It says, Josephina surveyed 298 students and found that 52% like scary movies. Estimate the number of students that like scary movies. So we're trying to find out what is 52% of 298 students. Now, the first thing it says to do is write the common percents from 0 to 100 at the top of the bar diagram. So what is this here? 100 broken into 4 parts. So what would that be? Half, it would be 50%, right? And then this would be a quarter, so 25%, and then 75%. Now, what's going on down here? 0, 75, 150. We must be going up by 75 each time. So 75 more than 225 is 300. What common percent is 52% close to? So 52% is closest to 50%, right? So that's like we're estimating here. We're kind of rounding. 52 is close to 50. And then it says round 298 to the nearest 100. So 298 is close to 300. Write your answer in the box below 100%. Oh, we already did that. All right, well, use the bar diagram to estimate 52% of 298. So look at 100% of 298, which is basically 300, is here. 75% would be around 225 students. 50% would be around 150 students. So you could safely say, you know, about 50% of 300 students is 150 students. So there's your answer, 150 students. Let's try this one. Use a bar diagram to estimate 73% of 400. So if you do this again, 25, 50, 75, 100, 100, 200, 300, 400. So what's about 73% would be about 75%. About 75% of 400 is 300. So we are going to be doing a couple things. We're going to learn 3 methods. Turn to page 138 and 139. When talking about estimating the percent of a number on this page, we are going to talk about turning the percent to a fraction and drawing a diagram. So I want you to write that down. So the first thing we're going to do, number 1, when we estimate, is turn the percent to a fraction and draw a diagram. So that's this page. If you need to pause it and get that written in, do it. All right, then the second thing we're going to do on the next page is we are going to do the same thing, turn the percent to a fraction. So number 2 over here, we're going to turn the percent to a fraction, but instead of drawing a diagram, we're going to write an equivalent fraction. So number 1, turn the percent to a fraction and draw a diagram. This one, turn the percent to a fraction and write an equivalent fraction. And then the third thing, the last thing that we're going to do is we're going to think about the percent as a rate per 100. So this is number 3. Number 3 is we're going to think about the percent as a rate per 100. Pause that if you need to get it. Here's our overall thing. We've done all of this stuff before. We've drawn bar diagrams in our first chapter with rates and ratios. In the first chapter and this chapter, we've been writing equivalent fractions like craziness. And then this chapter, we've really been focusing about thinking as percents as rates out of 100. So this is nothing new. All we're doing is what we've already learned to help us estimate the percent of a number. Here we go. Page 138. Estimate the percent of a number. Estimating with percents will provide a reasonable solution to many real-world problems. Hey, let me pause right there. Think about this. You go shopping and you're like, oh, something's 30, I have a 30% off coupon. So this shirt is $20. So if it's 30% off, how much am I going to pay? So when they say that it's a reasonable solution to real world problems, it's something that you're going to use a lot with shopping in particular. So what we need to do is when we're estimating is choose compatible numbers. Let me remind you what that meant. When we were on this last page, a compatible number to 52 was 50. A compatible number to 298 was 300. So what we're going to do in this is we're going to make nice, easy to use compatible numbers when we're estimating. So this is our key here. These are the kind of numbers we're going to use in this lesson. All right. So in these first two examples, remember we're turning the percent to a fraction and drawing a diagram to solve our problem. We need to estimate 47% of 692. Well, let's choose compatible numbers. 47% is close to 50%. Now, 692 is close to 700. We need to turn the percent to a fraction and draw a diagram. So that's why here they're saying 50% you know is 1/2. All right, because 50% is 50 hundredths, and that can be simplified to 1/2. So here we go. Think about a bar diagram. You have 700 is 100%. So what's 50%? What's half of 700? And that's 350. So 47% of 692 is about 350. All right, let's look at the next example. Estimate 60% of 27. All right, well, first thing we have to do is turn the percent to a fraction and draw a diagram. So think about that. 60% is 60 out of 100. When you simplify that, if you divide by 20, you get 3/5. That's where they got this right here. 60% is 3/5. So then you draw a diagram. So 60% of 27, 27 rounds down to 25. That way it's divisible by 5 because we're going to break it down into fifths. So if you have this diagram right here, 100% of the diagram, that's like 5/5. See, 1, 2, 3, 4. We broke it into fifths. This is 4/5, 3/5, 2/5, 1/5. 100%, 5/5 is 25. That's the number we rounded this down to 25. So 5, 10, 15, 20, 25. How much is 3/5? 3/5, 60% is 15. So 3/5 of 25, 3 times, okay, wait, 3/5 of 25. Oh, that's just saying this here, 5, 10, 15. 60% of 27 is about 15%. Because 3/5, 60% of 25 is 15. Let's try some of these. All right, we have a few examples down here. Let's do this one. Let's make these compatible numbers. So what's really compatible to 48%? 50%. And, okay, 76, that's right. Well, here's the deal. 76 actually rounds up to 80. Watch how this can work. Because watch, if you did 75, you'd have to think about what's half of 75. It's easier to think about what's half of 80. Because if you think of your bar diagram here, and you have 80, so a whole, 50%, half, or I'm sorry, that would be 100%, half, 50% of 80, half of 80 is 40. It's easier to think of half of 80 than it is to think of half of 75, so 80 is a more compatible number. So half of 80 is about 40. So your answer there for A is about 40. So what if you're thinking 18% of 42? Well, 18%, it's easier to think a more compatible number is 20%. So by the way, our process here, turn the percent to a fraction and draw a diagram. Here, the percent was turned to half. So 20%, what fraction is that? If you don't remember, 20% is 20 hundredths. When you divide by 20, that gives you 1/5. So we're talking 1/5 of 42. Now what's a compatible number? 5 can go into 40. So if you think about what's 1/5 of 40, if you have 40 here and you divide it into 5 sections, this would be 5/5, 100%, 5/5. We need this right here, 1/5. What would 20% be? 1/5 of 40. Well, what's 40 divided by 5? 8. So 1/5, 40, each of these sections is 8. 1/5 is about 8. So 20% is about 8. 18% of 42, 20% of 40 is about 8. All right, let's do this one. 73% of 41. Easier number for a percent is 75%. And we know that fraction, 75, we want to turn this to a fraction. Divide by 25 gives you 3/4. So when you draw a diagram, 3/4, 1/4, 2/4, 3/4, 4/4. This is 25%, 50%, 75%. We're looking for this. And the number 41 is real close to 40. So how do you break 40 into 4? 10, 20, 30. So we're looking for 75%, 3/4, 75% of 40 is 30. So these are our estimated numbers by finding those compatible numbers, turning them into fractions, and drawing a bar diagram. Let's look at method 2. Same thing. We're going to find compatible numbers. We're going to turn the percent to a fraction, but this time we're going to write an equivalent fraction. So let's look at the example provided here. Polar bears can eat as much as 10% of their body weight in less than 1 hour. If an adult male bear weighs 715 pounds, about how much food can he eat in 1 hour? To determine how much food a polar bear can eat in 1 hour, you need to estimate 10% of 715. So 10%, that's already an easy compatible number. 715 is similar to, it's real close to 700. So think about this. Turn 10% into a fraction. 10% is 10 out of 100. That's how they got the 1/10. When you divide by 10, you get 1/10. So 10% is 1/10. 715 is close to 700. Here's how we can set up our equivalent fractions. 1/10 equals what over 700? What percent of 700? So 1/10 is what percent of 700? We're looking for, not really a percent, but we're looking for this number out of 700. 1 out of 10, just like 10 out of 100, is what out of 700? So here we go. 10 times 70 is 700. 1 times 70 is 70. So 10%, it's easier if you think about it like this over here. It makes a little more sense. 10%, 10 out of 100, which simplified to 1/10, is equivalent to 70 out of 700. So 10% of 700 is 70. That's your answer right there. This is how they thought about it mentally. 10% is 1/10. 715 is about 700. 1/10 of 700 is 70. So it's just saying mentally, you kind of might just know that 1/10 of 700 is 70. And that's how you might have just mentally gotten to that answer. What I'm going to ask you to do is show me that equivalent fraction, because when we do the next lesson, you're going to need to set this up as equivalent fractions. So here we go. Kaylee decided to donate 30% of her savings. If she has $238 in her savings account, about how much will she donate? Now, here's the deal. We need compatible numbers. 30 is already a good number. 238 is really close to 200. So let's use that number. Now, the first thing we need to do is turn this percent into a fraction. So 30% equals 30 out of 100. Now, we could keep it like that, or we could simplify it. So in the examples, they've been simplifying it. Let's go ahead and simplify it. When you divide by 10, it's going to give you 3/10. So now we need to set up an equivalent fraction. We had this percent here, 30% of 100. So to find out what percent of 200, we set up 3/10 equals what out of 200? 10 times what is 200? 10 times 20. 3 times 20 is 60. So 30%, 30 out of 100, is equivalent to 3/10, which is equivalent to 60 out of 200. So this right here is the amount of money. And if you think about it, $60 is about 30% of $200. Like if you were to think of that as a bar diagram too. Now, if you were thinking mental math here, you have this 3/10. What if you thought 1/10 of 200? Mentally, you can think 1/10 of 200 is 20. So 3/10 of 200 would be 3 times 20, which would be 60. So mentally, you might think that out too if you're thinking of this method too. Either way, you get to this idea of $60. And we really want to focus on equivalent fractions, like I said, because it's going to get us ready for our next lesson. Now, before we go down to this, I just want to do one thing off to the side here so this can make sense to you. When you have 30%, you think of that as a rate out of 100. 30 out of 100, 30% out of 100 is what out of, in this case, was 200. That's why we set it up this way. That's why we set up the equivalent fraction with, we're trying to find this right here. Because 30% is this out of 100. So what is 30% of 200? What's the equivalent fraction? You could have set it up like this. 30 times 2 is 60. We just simplified it before we went over there. You didn't really have to simplify it. I'm writing it this way so you can understand why we set up the equivalent fraction that way. This directly ties into our third method, which is think about the percent as a rate per 100. So if you think about 17% of 198. That is similar to thinking of 17 out of 100. Now 198 is really close to 200. So if 17% is 17 out of 100, then it's like double that for 200. Double the 17. Look, since 200 is 100 plus 100, you can just do 17 plus 17 to estimate 17% of 198. 17 plus 17 is 34. So 34 is about 17% of 198. So if 17% is 17 out of 100, it's double that out of 200 because 200 is double 100. All right, let's try one of those. This is actually, it sounds a little complex, but it's actually easier than it sounds. All right, here's the example for that. An airline records the snack orders of passengers. Last year, 9% of all passengers ordered ginger ale to drink. There are 408 passengers on the flight to Houston, Texas. About how many passengers does the airline expect to order ginger ale in this flight? So we're trying to estimate 9% of 408 so we can find out what 9% of 408 is because 9% of that many want ginger ale. So we need to know how many people want ginger ale. So what's 9% of 408? Now, if you think about this rate as out of this percent as a rate out of 100, it's like 9 out of 100. And 408 is about 400. So 9 out of 100 is what out of 400? It's kind of like setting up an equivalent fraction. You're just timesing by 4. So 100 times 4 is 400. 9 times 4 is 36. So that's why they did this here. Multiply 9 times 4 to estimate 9% of 400. 36 is about 9% of 408. So about 36 passengers will order ginger ale. Let's do these ones together. All right, we're going to use the rate per 100 for this one. So think about 307 as 300. 27% is 27 out of 100. So 27 out of 100 is how many people out of 300? Times 3. So what's 27 times 3? 27 times 3 is 81. All right. So 81 is our answer. It's kind of like taking 27 plus 27 plus 27 gets you 81. 27 out of 100 plus 27 out of 100 plus 27 out of 100 gives you how many out of 300, which is 81. Think of this way. 192 is like out of 200. So 76% is 76 out of 100. We need out of 200, so we need 2 76s. So 76 times 2 is 152. So it's like taking 76 twice. 76 plus 76 is 152. Because we're thinking of 200, not 100. All right. Last year, 24% of the zoo visitors were under the age of 3. Last week, the zoo had 996 visitors. So about how many of the zoo visitors were under the age of 3? What's 24% of 996? So that's like thinking, what's 24% of, that's real close to 1,000. So 24% is like 24 out of 100, but we're talking 1,000. So it's times 10. So 10 24s, 24 times 10 is going to, you just add the 0, 240. So that's 240 of those visitors were under the age of 3. All right, our next step is to practice this in the guided practice. So you're going to try one, and then you're going to push play and see how I did it. All right, for our guided practice today, on page 140 for lesson 6 in chapter 2, we are going to do number 1, number 3, and number 5. Okay, so let's talk about how number 1 and number 3 are like examples 1 and 2. So that means you're going to want to turn the percent to a fraction and draw a diagram. You might want to set up an equivalent fraction, even though we did that in step 3. If you want to, you can do an equivalent fraction too. The diagram is good too. I'm going to show you both. So you go ahead and pause this, estimate 19% of 53, and then push play, and I'll show you the bar diagram and the equivalent fraction way. All right, go ahead, pause it and do it. Okay, so let's see here. When I attack this problem, I'm trying to find compatible numbers. So I'm thinking 19% is easier to say 20. And I'm thinking $53, it's easier to say $50. So I'm thinking 20% of $15. And if I think about that 20% as a fraction, I'm thinking about that as 20 out of 100. Now, to simplify that, if I divide by 10, it's going to give me 2/10. So I'm thinking, what's 2/10 of 50? So if I draw a diagram here, and I break 50 into 10 spots, 10, 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 2/10 of 50. Well, what's 50 broken down into 10? 5, right? So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. 2/10 of those would be 10. So I'm thinking this number is going to be 10. 1/5. Oh, look we could have even broken that down more. Did you break that down into 1/5? Divide by 2. Divide by 2. 1/5. That would have been even easier to draw, because then you would have only had to draw 5 parts. Man, you probably did that better than I did. So 1/5 of 50, 10, 20, 30, 40, 50. 1/5 would have been 10. Now, did you set up an equivalent fraction? 1/5 equals what out of 50? 5 times 10, 1 times 10. 10 out of 50. Either way you do it, even if you didn't simplify like I didn't, drawing the diagram or drawing the equivalent fraction, your answer should be 10. All right, let's look at number 3. 59% of 16. So let's think about 59%. That's like 60%, right? And 16 is roughly 15. It's real close to 15. So let's think about 60% as a fraction, because that's our first step. So 60% is like 60 hundredths. And if you simplify that, now let me try to simplify by the greatest common factor this time and get a better number. We can divide by 20. So that is going to give us 60 divided by 20 is 3. 3/5. Now, you could draw a diagram. So if you drew a diagram, you have fifths here. 1, 2, 3, 4, 5. We're looking at 3/5. 3/5 of 15. All right. How do you break 15 into 5? 3, 6, 9, 12, 15. 1, 2, 3, 4, 5/5. 3/5 is 9. Can you get the same thing with an equivalent fraction? 3/5 equals what out of 15? 5 times 3, 3 times 3, 9. So either way you do it, you turn it to a fraction. You can draw it or you can set up an equivalent fraction. Either way you get 9. Let's try number 5. Mr. Marcucci receives a bonus of $496 from his employer. He has to pay 33% of his bonus to taxes. So how much will he pay in taxes? Think about this one like examples 4 and 5. So think about this as how much, in this case it was 9 out of 100, 9%. Think of how much it is out of 100 with the percent. And then multiply to get to the closest 100. Look at what numbers we're using here. 33, think of that as 33 out of 100, and 496 is close to 500. So pause it, try to use that rate method out of 100 to get your answer for this one, then do it with me. All right, so I'm thinking 33% is 33 out of 100. This 496 is roughly $500. So I'm thinking I need 5 33s. 33 plus 33. It's like you can add it 5 times, or you can multiply it by 5, right? Because you're thinking, what is it to 500 times 5 times 5? So 33 times 5 is 165. So 33% of $496 is roughly $165. All right, your next step is independent practice, so on your own practice. So we are on page 141 for lesson 6. Here are the independent practice problems that you need to do. Number 1, number 2, number 5, number 6. So number 1 and 2, it's just like examples 1 and 2. Use the bar diagram, set it up as a fraction, use a bar diagram or equivalent fraction. And then in these two, you can use that thinking about it as a rate of 100 and multiply. I like to set it up as equivalent fractions too, but think of it out of 100 because this is really close to 300 and this is really close to 200. All right, go ahead and do those 4 on your own. All right, it's time to check your answers for independent practice, page 141. So let's take a look at number 1. In number 1, think of 47% as 50 and $118 as 120. Now, 50% as a fraction is 50 out of 100, which is 1/2. If you think about half of 120, half of 120 is 60. If you set up the equivalent fraction, half equals what out of 120? Multiply by 60, it gives you 60. Your answer is 60. In number 2, 19% is compatible to 20. 72 is compatible to 70. Turn it into a fraction. 20% is 20 out of 100. Simplified is 1/5. 1/5 of 70 is 14. 14 times 5 is 70. Set it up as equivalent fraction and it looks like this. 1/5 equals what over 70? Times 14 gives you 14. All right, let's look at number 6. This is thinking of the percent as a unit rate. 67% of 208, think of it as 200. 67% is 67 out of 100. So you need 2 to get to 200. 2 67s is 134. Or if you thought of it as multiplying, 100 times 2, 67 times 2 is 134. Next step, the learning objective reflection. All right, let's take a look at the learning objective reflection for Chapter 2, Lesson 6. Learning Objective F says, I can estimate the percent of a number. Looks like we have 1, 2, 3 parts to this. The first part, when estimating, you need to choose blank numbers to work with. So what kind of numbers did we call that in the book? If you want to look back in the lesson, it was right in the lesson. What kind of numbers do we want to work with? And then show examples. What is 49 close to? What number? What number is 26 close to? What number is 28 close to? So that's number 1. And then for number 2 and number 3, we're going to look at the main methods of how we estimate the percent of a number. So number 2, one way to estimate the percent of a number is to turn the percent into a blank and then draw a blank or set up an blank blank. So this was like the first 2 things actually that we looked at in the chapter. Now, using this method, do the example. Here's my work to show how I would estimate 76% of 39. Now, the last method that we looked at in the book was something different. That's number 3. If you are estimating the percent of a number that rounds to a multiple of 100, the best way to estimate the percent of the number is to think of the percent as a blank per blank. So if the number that you're finding the percent of is close to something like 100, 200, 300, multiple of 100, then what do you want to think about in terms of the percent? You want to think of it as a blank per blank. So this was the last method we looked at. If you want to look back in the book and check yourself. Here's an example using this method. Here's my work to show how I would estimate 27% of 302. So look at 302 is really close to 300. So you can keep this 27 the same and use this method here in number 3 to estimate the 27% of 302. All right, go ahead and do that, and then do the learning objective check-in.